Ions are atoms that carry a charge, either positive or negative. Let's take a look at oxygen, which is atomic number 8. You see, atomic number 8 means that there are 8 positively charged protons in its nucleus and 8 electrons surrounding it to balance that charge in the case of neutral oxygen, as it says at the bottom of your screen. Neutral oxygen has these two balanced out to be a zero charge. Now, neutral atoms aren't necessarily stable. Stability is met by having an outermost orbital that's full, and oxygen achieves this by picking up 2 extra electrons. So now we see that the outermost or valence shell is full in the case of oxygen, and of course this means that it has 8 valence electrons. Thus we call this the octet rule. An atom is most stable when that outermost orbital is full, which typically means having 8 valence electrons. So now if you look at the bottom of your screen, you'll see that now we're talking about stable oxygen, which has 8 protons, but now 10 electrons total, which means that its net charge is now a -2 because of the addition of those 2 electrons. Positively charged ions are called cations, as in the case of magnesium, which results from a loss of valence electrons. Atomic number 12 for magnesium means that it has 12 positive charges in its nucleus and a total of 12 negative electrons surrounding it. Now those 2 negatively charged electrons in its outermost orbital then are easily lost in the case of magnesium, so that magnesium ion then has a full outer orbital and meets the octet rule, that full outer orbital of 8. And we see here that now when we count up protons and electrons, there are an additional 2 protons over electrons, thus giving magnesium ion a net +2 charge. In the case of fluorine, we see that it will normally form a negatively charged ion, which is called anions, and this results from the gain, then, of valence electrons. So fluorine is atomic number 9, which means that it has 9 protons, and in its neutral state, 9 electrons for a 0 charge, which means it also has 7 valence electrons and thus easily picks up that 8th valence electron to have its full outer orbital, thus fulfilling the octet rule. And now we see that fluoride ion has 1 additional electron over the protons and thus carries a -1 charge. So press pause at the bottom of your screen and take a moment to answer the following for each of these ions. Are they cations or anions? How many total electrons do they possess? And how many valence electrons do they possess? Okay, so for sodium ion, you see it's positively charged, which means it's a cation. Now if we do our orbital diagram for sodium in the neutral state, we see that it has that 1 valence electron on the outer ring. That 1 valence electron is easily lost to fulfill the octet rule and give sodium ion a stable outer orbital. And we also see that this results in 1 additional proton over electrons, giving it a +1 charge. So there are a total now of 10 electrons, and only valence electrons being counted, we see that it has 8. Which of course is the reason it lost that 1, is to fulfill the octet rule and have the 8 valence electrons. For oxygen ion, we see that it's an anion because it's negatively charged. And looking at its orbital diagram, we see that it has those 6 valence electrons in its neutral state, and oxygen likes to pick up those additional 2 electrons to give it a full outer orbital. And thus, with the addition of those 2 electrons, it now has a total of 10 electrons, but again, fulfilling the octet rule and giving it an 8 count for its valence electrons. Hydrogen ion, in this case, is a cation because it has a positive charge. We see in its orbital diagram 1 positively charged proton at the center and 1 negatively charged electron surrounding it. That 1 lonely valence electron is often lost, thus giving hydrogen ion a net +1 charge. Total electrons are 0, and of course total valence electrons are 0. Finally, with chloride ion, we see it has a -1 charge, thus it's an anion. And when we do its orbital diagram, we see 2 electrons in the first orbital, 8 in the second, and a 7 valence electrons in its neutral state to add up to 17 to balance its atomic number. So chloride likes to pick up that additional electron in its outermost orbital, giving it a full octet, and thus having one more electron than number of protons and giving it a -1 charge. Thus, total electron number is 18, and valence electrons is again 8.